Last class we discussed differentiation rules for logarithms. And as you know from chapter 4, integration is really just the reversal of the derivative rules. So now that we know the derivative rules, we can reverse them. So we have these kind of basic integral of 1 over x dx is a natural log of absolute value of x plus c, and 1 over u du gives us natural log of the absolute value of u plus c. So we're going to use u substitution, and we're basically just combining our knowledge of u substitution with these new patterns that we have. Alright, so not every single problem we do is going to include this pattern, but that's sort of another tool in our toolbox that we can use as we move along. Some of these are very simple u substitution problems, and others are a little more complicated and a little more obscure or obtuse, a little harder to see. So let's take a look at a few of these. The first one, we have 5 over x dx, and of course we can just pull that constant out in front of the integral, and we have 1 over x dx, so it just fits that pattern. Very, very simple. So we get 5 natural log of absolute value of x plus c, and we can then, since this is a logarithm, we can bring that 5 and make it the exponent on the x and simplify that answer just a little bit. So that one's pretty straightforward. The next one's also pretty straightforward. We have 1 over x minus 5 dx, and if we let u equal x minus 5, then du is just dx, and so we can just, using this u substitution, rewrite that as 1 over u du, and then it integrates to ln of absolute value of u plus c, and we plug that x minus 5 back in for the u. So those two are kind of good warm-ups, sort of a reminder about our u substitution basics, but nothing too complicated or really exciting. Let's take a look at this next one here. All right. So this is a definite integral. Okay, we have a definite integral. So we are looking at the u substitution. Okay. Now if we let u equal 3 minus x cubed, then du is negative 3x squared dx. So this du does in fact get us our numerator and the dx. It gives us our x squared dx. But it kind of gives us this extra negative 3 that we don't really want, so we're going to offset that with a negative 1/3. And so that's pretty standard u substitution stuff. But remember, this is a definite integral now, so we've gone sort of into the u realm. And so what I want to do is rewrite my integrals. Rewrite my upper and lower limits so that they are now in terms of u. These were in terms of x equals 0 and x equals 1. So to find my new limits, I have to say, okay, well, u equals 3 minus 0 cubed. So now I have a lower limit of 3. And then u equals 3 minus 1 cubed. I have an upper limit of 2. All right, so that gives me my new lower and upper limit. Now when I actually do this integration, I just have negative 1/3. Now I'm going to have the ln of u evaluated from 3 to 2. Negative 1/3 ln of 2 minus ln of 3. And that is just negative 1/3 ln of 2/3. I may be able to rewrite that. I could rewrite that as ln of 2/3 to the negative 1/3, something of that sort. But essentially I have the integration done there. If I had a calculator, I could maybe evaluate that as it's written. I could just leave it in terms of natural log.